So next in unit 1, we talked about factoring and solving. So number 9 says solve by any factoring method. So they're not specific, but at least they tell us that we can factor. When we're factoring, I would always start by setting your equation equal to 0. So I'm going to start by subtracting x from both sides. So we have x squared plus 8x. Well, no, sorry, not plus 8x. 8x minus x would be a plus 7x, and then minus 18 equals 0. When we have a trinomial, a quadratic trinomial, because we have 1, 2, 3 terms, I'm going to try to think of two numbers that add to equal 7 and multiply to equal a negative 18. And that would be what would that be? Let's see, if we're struggling to come up with a number like I am right now. Let's make our factor tree of 18. So let's see, 18 can be 1 and 18. That's not going to work. 2 and 9. Okay, there we go. You could also try 3 and 6. I clearly was just struggling there. So we want 2 and 9. And I want, let's see, 2 plus 9 is not 7. But if I change this to a negative 2 plus 9 would be 7. And negative 2 minus 9 would be a negative 18. Sorry. So our factors, we would write this as x minus 2 times x plus 9, and we keep it equal to 0. Next, by our 0 product property, I'm going to set each of these parentheses equal to 0. Set each factor equal to 0. Solve for x. So I'll add 2 to both sides, get x equals a positive 2. Subtract 9 from both sides and get x equals a negative 9. There we go. Part B, I would start B the same way by setting it equal to 0. Subtract 25 from both sides. We have x squared minus 5x, negative 25 minus 25. So that'd be like I owe you $25 and I owe you 25 more dollars. I now owe you $50. And now it's equal to 0. We have a trinomial where a is equal to 1. So there's a 1 in front of that x squared. So we think of two numbers that add to equal negative 5 and multiply to equal a negative 50. And that would be a negative 10 and a positive 5. So I like writing it out this way because it requires me to check, is negative 10 plus 5 a negative 10? Yes. Is negative 10 times 5 negative 50? Yes. So I might write my factors as x minus 10 times x plus 5, still equal to 0. And then we are going to set each of these factors or parentheses equal to 0. And solve. So I'll add 10 to both sides, get x equals 10. Subtract 5 from both sides, and x equals a negative 5. You can either write your answers out as two separate numbers, or it might be easier to just make a list and write it as 10 comma negative 5. Okay, part C. Once again, we do not have our equation equal to 0, so I'm going to start by subtracting x and subtracting 24. So we have 4x squared minus 4x minus 3 equals 0. This is a different type of factoring because our number in front of x squared is not equal to 1. So I'm going to do the slip and slide method or the slide and divide method, or I personally call it the cloud method, because I'm going to set the 4 off to the side. I'm going to put this in this cute little cloud so I don't forget about it. I'm going to bring it down as x squared minus 4x. And in that same step, I'm going to multiply 4 times negative 3 to get a negative 12. From here, we're factoring. So we're going to think of two numbers that add to equal a negative 4 and multiply to equal a negative 12. And that would be a negative 6 and a positive 2. So we have x minus 6 and x plus 2, and this is still equal to 0. Then yes, we factored, but we forgot that we need to take that 4 that I took out and then I randomly multiplied, and I need to undo that random multiplication with division. So I'm going to divide both of these terms by 4 and reduce our fractions. So 6 over 4 becomes 3 over 2 because I can divide the top and bottom by 2. 2 over 4 reduces to 1/2. I can divide the top and bottom by 2. This equals 0. Now, technically, because this question is asking us to solve, I don't need to move these denominators next to the x, because that would just cause me to put them back later. So I'm just going to set each of these factors equal to 0. And then I'll add 3/2 to both sides. So my first answer is a positive 3 over 2. My second answer, I want to subtract a negative 1/2 from both sides, and I get x equals a negative 1/2. Okay, number 10, we do not have an equal sign, so we are only going to factor and then stop. So for part A, looking at these, I know that 9 and 36 are perfect squares, and I'm subtracting. So this is the difference of squares pattern, which means I want to square root 9x to the 6th. The square root of 9 is 3. The square root of x to the 6th is x to the 3rd, because I take the exponent and I divide it by 2 because I'm taking the square root. So 6 divided by 2 is 3. And that's how I got this exponent. Then we have the square root of 36 is 6. So I'll have one parentheses with 3x to the 3rd plus 6 and 3x to the 3rd minus 6. And that is our difference of squares pattern. For part B, at the moment, these are not perfect squares and they don't seem to be perfect cubes either. So we're going to look for a GCF. We're going to take out a 2x. If I take out a 2x, I'm left with an x to the 6th plus 27. So now this is my sum of cubes, and I need to apply my SOAP pattern to it. The GCF stays out in front. I'm going to think of the cube root of x to the 6th. 6 divided by 3 would be 2, so I get x squared. The cube root of 27 would be 3, so there's a 3 in here. Now the word SOAP is an acronym to help you remember the signs. The S stands for the same signs. There's a plus here, so there's going to be a plus in that parentheses. The O stands for opposite sign, so the next sign is going to be a minus. And then the last sign is always positive. There's always going to be a plus there. To fill in the blanks, we're just going to multiply our first parentheses. So we're going to start by multiplying x squared times x squared is x to the 4th. Then to find the middle term, I'm going to multiply x squared times 3 to get 3x squared. And our last term, I'm going to multiply 3 times 3 to get 9. And this is my final answer. Part C, we have 1, 2, 3, 4 terms. When you have 4 terms, you have to factor by grouping. So 4 or more, you're forced into grouping. So you want to pick 2 groups that have GCFs. So this first group looks like it would have a GCF of 4x to the 3rd. When I took out that 4x to the 3rd, I would be left with 2x plus 1. The second group has a GCF of a negative 3. When I take out a negative 3, I am left with 2x plus 1. So when these parentheses are exactly the same, that is going to be your first factor. So we'll have 2x plus 1. Whatever is out in front, so in this case, we have a 4x to the 3rd minus 3, will be over here. Sorry, I just realized I kind of messed up part A. We're going to fix it because I know that's probably what you wrote down. So we're going to backtrack a little bit. So I was looking at part A and I was like, oh, that answer looks a little funny because if you look, we have a 3 and a 6 and another 3 and a 6. That means that I missed my GCF. So I could have taken a GCF out in my very first step. But it's okay because we did this. So we're going to roll with it. Oh, I lost my 6 now. So I'm going to take a GCF of 3 out of that first parentheses and then a GCF of 3 out of that second parentheses. Oh, we're okay. So when I take each of those GCFs out, I'm going to multiply them together. I'm going to move into number 11 a little bit. So that's not my answer anymore. So we take out a 3 from the first parentheses and a 3 from the second parentheses. So that was that one. That was that one. Then when I do that, the first parentheses, we're only left with x to the third because 3 divided by 3 cancels. And 6 divided by 3 would be 2. Second parentheses, when I take 3 out, we would just be left with x to the third minus 2. So our final answer, when you take both those GCFs out, would be a 9x to the third plus 2, x to the third minus 2. So this would be our final answer. That whole thing could have been avoided if I had double checked for GCF in the first step. I would have seen that 9 goes into both of those, and I could have taken my GCF out in the first step. So if that whole conversation confused you, then you need to make sure that you always take your GCF out in your very first step. It can technically be done in the last step, but it can be a little confusing, especially if you have multiple GCFs going on. Okay, I'm going to clear all of this writing off. So if you haven't finished copying it down, I would pause the video. And number 11, solve by taking square roots. So with these problems, you'll notice that we only have an x squared. There's not like an x squared and an x. So our goal is to first isolate the x squared. So I'm going to start by subtracting 4 from both sides. And then dividing both sides by 2. So we have x squared equals a negative 12. From here, to get rid of the squared, I'm going to square root both sides. So the square root and the squared cancel. We're left with x. On the right side, whenever you square root both sides, you need the plus or minus symbol. 12, we're definitely going to have an I because of that negative. 12 can be broken into 4 and 3. And because 4 is a perfect square, we can take that out. So the square root of 4 is 2. We want the I because there's that negative sign, and then there's a 3 left over. So this answer would be plus or minus 2I root 3. For part B, we're going to start by subtracting 2 from both sides. We have 6x squared equals 486. Then we'll divide both sides by 6. Get x squared equals 81. From here, I want to square root both sides. So the square root and the square cancel. We're left with x. Whenever I square root both sides, I need the plus or minus symbol. And we know that the square root of 81 is 9. So our answer is just plus or minus 9. Part C, this one's going to be a little bit more labor intensive because this x minus 3 squared, we actually need to multiply out x minus 3 times x minus 3 and then combine like terms. I actually don't know if we can solve by taking square roots, but we will see. We'll see what happens here. So we're going to start by foiling. So we're going to leave the 2 out there. X times x is x squared. X times a negative 3 is a negative 3x. Oh, wait, hold on. I am overcomplicating things right now. I know what this problem, I think I know what this problem wants us to do. I think. Yes, I got a better idea, better plan. You could technically do this. I'm making it harder than it needs to be, so we're going to backtrack. The reason I paused at the very beginning is because it says solve by taking square roots, and I need to read the instructions and actually process it. So keeping with the A and the B, we have something being raised to the power of 2. So I want to move things away from that. So I'm going to start by adding 5 to both sides. There we go. This problem just got a lot easier. 51 plus 5 is 56. Then I want to divide both sides by 2. And we get 28. Then we want to square root both sides. To get rid of the squared, we're left with x minus 3. The square root of 28, it's not a perfect square, but I can break this into 4 and 7. And I know that the square root of 4 is 2, and then there's just going to be a leftover 7. Our last step would be to move this 3 to the other side. So we get x is equal to 3 plus or minus 2 root 7. Sorry about that. I was looking ahead. Okay, number 12, solve using the quadratic formula. So for these, you always want to have it equal to 0 before you begin. So I'm going to start by subtracting 2x and adding 2 to both sides. We have 2x squared minus 3x plus 5 equals 0. So in our quadratic formula, we have a equal to 2, b equal to -3, and c equal to 5. So our quadratic formula says, let's go ahead and write this up here. X is equal to the opposite of b. So if b is a -3, the opposite would be a +3, plus or minus the square root of b squared. We know that b is -3, so b squared will be a +9. Then we have minus 4ac. A -4ac or a minus 4ac would be -4 times 2 times 5. Looking at my A and my C. So that would be -8 times 5, which is a -40. So there's going to be a -40 here. And this is all over 2a. And if a is 2, 2 times 2 is 4. So we want to simplify our radical. So we'll have 3 plus or minus 9 minus 40 is a -31 all over 4. 31 is prime, but I can take out the -1 as an I. So we have 3 plus or minus I root 31 all over 4. And that would be our final answer. Part B, we want to rearrange this, start by subtracting 4x from both sides. So we have 2x squared minus 4x plus 5 equals 0. Then I want to identify my A, B, and C. So A is equal to 2, B is equal to a -4, and C is equal to 5. So my quadratic formula says x is equal to the opposite of B. So that'd be a +4, plus or minus the square root. You know what I didn't actually finish writing was all over 2a. There we go. Plus or minus the square root of b squared. So -4 squared is 16. The minus 4ac, that would be -4 times 2 times 5. 4ac, there we go. So that'd be -8 times 5, which again is a -40. And this is all over 2a, so 2 times 2 is 4. From here, we simplify our square root. 16 minus 40 is 16 minus 40. That would be, oh my gosh, 24. All over 4. I need to take out any perfect squares from that radical. So I can break this into 6 times 4. Because I know that the square root of 4 is 2. Oh, it's a negative. That's what I also forgot. My brain fart caused another mistake. Okay. So 16 minus 40 was a negative 24. Still breaking this into 6 times 4 because the square root of 4 is 2. That negative sign is an I, and then we have a leftover square root of 6. And this is all over 4. Next, we want to double check, is there anything that goes into 4, 2, and 4? Yes, we can reduce this fraction by 2. So our final answer is 2 plus or minus I root 6 over 2. Okay, M part C, we want to subtract 10 from both sides. We have 5x squared minus 2x minus 10 equals 0. Solving using the quadratic formula, we want to identify A, B, and C. Then I want to plug into our formula. So we have x is equal to the opposite of b. So if b is a negative 2, I want a positive 2. Plus or minus the square root of b squared. So that would be a negative 2 squared is a positive 4. Minus 4ac. So I'm going to do negative 4 times a, which is 5, times c, which is a negative 10. So it'd be a negative 20 times a negative 10, which would be a positive 200. So I'm going to put a plus 200 all over 2a. So that would be 2 times 5 is 10. We add, we get 2 plus or minus 4 plus 200 will be 204 all over 10. Let's see. Perfect squares that go into 204. I can break this into 4 and 51. So the square root of 4 is 2, and there's a leftover 51 inside the radical, all still divided by 10. So our last step would be to reduce something that goes into 2, 2, and 10 would be a 2. So our final answer is 1 plus or minus 1 root 51, or just root 51 all over 10. Okay, solving by completing the square. We are going to start by moving c to the other side. So I'm going to add 4 to both sides. We have x squared plus 8x. I'm going to leave a gap right here. Next thing I need to make sure of is that my coefficient of x squared is equal to 1, which it is. So then I look at my coefficient of b, and I'm going to this positive 8. I'm going to half it to get 4, square 4 to get 16. So there's going to be a plus 16 on both sides. Then I want to write this as a perfect square. What you can either factor it, or whatever number you get from having it will always go in the parentheses. So there's going to be a plus 4 right here. And 4 plus 16 is 20. From here, we want to square root both sides. So the square root and the squared cancel. We're left with x plus 4 equals plus or minus. Out of 20, we can take a 4. So the square root of 4 is 2. There's a 5 left inside. Then I want to finish by subtracting 4 from both sides. So I get x is equal to a negative 4 plus or minus 2 root 5. Part B. You can either set this equal to 0 first and then move your constant to the other side, or I'm just going to move the 43 over to join the 10. I don't need to have multiple. So we're just going to start by subtracting 43, and I will leave a gap here. 10 minus 43 would be a negative 33. And then I take my b term, which is negative 14, and I'm going to half it to get negative 7. -7 squared is a positive 49, and that's how I'm going to fill in the gap. So next, the number in the parentheses will be whatever I got from having it. So in this case, I had a -7. There's going to be a -7 right here. And -33 plus 49 is equal to a positive 16. Then we want to get rid of the squared. So I'm going to square root both sides. We're left with x minus 7. Whenever we square root both sides, it creates the plus or minus, and the square root of 16 is 4. From here, I want to add 7 to both sides. So I had x equals 7 plus or minus 4. You need to actually figure out like what is 7 plus 4 and then 7 minus 4 to get your two answers. So this would be 11 and 3. Okay, part C. Part C, very similar. I'm going to move all my constants to the right side. So I'm going to add 66 to both sides. So I have x squared plus 4x equals positive 57. Next, I want to take my coefficient of x, so my b term. I'm going to half it. So 4 divided by 2 is 2. Then I want to square it to get a positive 4, and then I want to add that to both sides. It will always be half, it will always be square. So then we write our parentheses as a perfect square. The number we got from having it was 2, so that's the number that goes in the parentheses. It's a positive, so there's a plus. And then 57 plus 4 is 61. Next, I want to square root both sides to get rid of the square. So we're left with x plus 2 equals plus or minus, and 61 is not a perfect square, nor does it have a perfect square that goes into it. So we just leave it as the square root of 61. And then we will subtract 2 from both sides to get x by itself, and that is our final answer. Okay, number 14, sketch a graph for each of the following, each of the 3 possible outcomes when solving a quadratic equation. State what the discriminant would be and what type of solutions for each graph. So your discriminant, like formula, is the b squared minus 4ac. If you get a positive number, any positive number, you are going to get 2 real roots. So you just want any type of graph that crosses the x-axis twice. So we got one over here, one over here. That's good enough. Okay, the next scenario would be if you do the b squared minus 4ac and you get some negative number. If you get a negative number, you will have no real roots. If they're not real, then they're going to have 2 imaginary. Means the same thing. So you want a parabola that does not cross the x-axis. So I'm going to do one that looks like that. So it's opening down and it's already below the x-axis. So it's never going to cross it. Then the third scenario is if you do your discriminant and you get something equal to 0, that would be 1 real root. It's a double root. So you want some parabola that touches the x-axis once and then bounces back up. Okay, the last 2 problems ask you to factor using any method of your choice. They're both already equal to 0, and they are both trinomials. So for part A, I would recommend that you just find two numbers that add to equal -4 and multiply to equal 7. Interesting. That's not possible. I think it's interesting that it says factor because that's not factorable then. Okay, so we tried it. So factoring is not an option. This one, we're gonna roll with it. Because we can't factor, then your other options are completing the square or the quadratic formula. So either quadratic formula or complete the square. So because we have these, we're narrowing it down to these two options. I will tell you though that because our x squared, the coefficient of x squared is equal to 1, and this is an even number, completing the square would probably be the better choice because it wouldn't be that bad. So I would start by moving c to the other side. And then you would half it, square it, add it. So take -4, half it to get -2. Square that to get a +4. And we have x minus 2 squared equals a -3. Because the number we got from having it was -2. Then we want to square root both sides. So I have x minus 2 equals plus or minus I root 3. Get x by itself. And that's our answer. For part B, you could try the cloud method or slip and slide. It would be kind of tricky. So if you were to do that, you would set the 3 off to the side, and you would ultimately be thinking of two numbers that add to equal 9 and multiply to equal a -30. So you got 2 and 15, 3 and 10, 6 and 5. So none of them are going to be factorable. I would not complete the square because this is not equal to 1. And this is, so this is not 1. And this is an odd number. So it's not going to be as pretty. So this, the importance of an even number is because you know you're going to half it. And it's just nicer if when you half it, you still have a whole number, not a fraction. If you did try to complete the square and that's not 1, you would just have to divide everything by 3. So fractions are inevitable if you try to complete the square. So I would actually quadratic formula this. Let's see, so my A is 3, my B is 9, and my C is a -10. So we'd have the opposite of B plus or minus the square root of B squared minus 4 AC. So -4 times 3 is -12. -12 times a -10 is a +120. All over 2A. So 2A would be 6. There we go. We have -9 plus or minus the square root of 201 all over 6. There is not a perfect square that goes into those, and they aren't all divisible. So this would be your final answer. If you really wanted to reduce the 9 and the 6, you could separate this out into -9 over 6, which would then reduce to -3 over 2. But that square root of 201 has to stay over the 6. So this is also correct. But I would imagine you just leave it as one big fraction.